Hello everyone and welcome to the second session of Wipro 3D's 3D Thursdays webinar series. I'm thrilled to have you with us today as we dive into the exciting world of additive manufacturing. It is my pleasure to host the session. My name is Akshita and I represent Wipro 3D. As many of you know, additive manufacturing or 3D printing is revolutionizing various industries. Our topic for the second session is advancements in additive manufacturing, government initiatives, and emerging opportunities in India. Before we get started, a few quick notes. Please keep your microphones muted to minimize background noise. We encourage an interactive session, so please feel free to ask questions. We will have a dedicated Q&A segment towards the end of the presentations, but you can submit your questions at any time using the chat feature. To ensure everyone has a chance to participate, we may group similar questions together. We'll address as many as time allows. Lastly, please note that this webinar is being recorded. By participating, you consent to the recording being shared for educational purposes. We're thrilled to have Dr. Shankha Das sir today with us, who will be sharing insights on the topic today. Dr. Shankha Das sir received BSc degree in physics and BTech and MTech degrees in radio physics and electronics from University of Calcutta and MPhil and PhD degree in electronics and electrical engineering from University of Sheffield, UK. He joined Ministry of Electronics and Information Technology, Government of India in 2015 as a scientist, which is his current role also. He is part of the core team for review and research, drafting and release of National Strategy for Additive Manufacturing, known as NSAM or NSAM. His current responsibilities include implementation of NSAM through self-sustainable centers in PPP mode. Currently, he is looking after 11 such centers, which are either running or under initiation. He desires to introduce inclusive and sustainable growth using additive manufacturing under Industry 5.0. Today, we'll explore several key topics that highlight the significance and potential of AM in our country. First, we'll discuss why additive manufacturing is considered a digital technology. Next, we'll dive into the potential of AM. We'll then explore the unique potential of AM in India, after which we'll introduce the NSAM or National Strategy for Additive Manufacturing 1.0, outlining its goals and objectives. We'll review the output of this strategy until the end of the year, highlighting key achievements with illustrations of successful projects. Following that, we will discuss the critical need for AM in India and how it addresses current challenges. Finally, we'll introduce the Center for Additive Manufacturing or NCAM and discuss its mission and collaborative efforts. Impressive, right? Let's welcome Dr. Shankha Das as he takes us through today's presentation. I'm confident you'll find this session both informative and inspiring. The stage is all yours, sir.
Am I audible?
Yes, sir.
Okay. Is my presentation visible?
Yes, sir.
Okay. Thank you. Thank you, everyone. This is a small effort towards creating an awareness, and you have to look at it from the point of view how industry can actually participate uh, to grow the additive manufacturing market in India. So the topic today is advancement in additive manufacturing, government initiatives and emerging opportunities in India. Uh, s- Before we look at what we are want to do in terms of policies and how to open up a market and so on, you have to understand that additive manufacturing, what is additive manufacturing? Well, there are many definitions around, but the primary point is this is a deposition, a material deposition or joining of materials from 3D printed model data, that is digital data, and you do that in layer upon layer style. And then you grow the parts that you want to create. So that is why it is a digital technology. The primary point being, this is when you introduce additive manufacturing into the manufacturing uh, sector, you actually digitize the manufacturing process. So that's why it's also known as a digital manufacturing. Uh, Also, this is a part of Industry 4.0, and also now it is into the Industry 5.0 as well. So Industry 4.0 technologies uses data analytics, AI, IoT, and cloud computing to enable smart factories and automated productions. And that's why AIM, additive manufacturing, is a digital technology. Now, the use of digital twins, this is where you will find that advanced manufacturing or industry 5.0 uses digital twins and threads in order to optimize the not only the supply chain but also optimize the process technology in terms of increasing its efficiency in terms of cost, material, manpower, etc. So going into aim will mean that you are going into a advanced manufacturing infrastructure, digital infrastructure, in order to produce a economy that will bring much higher pay jobs as compared to the manufacturing in industry 1.0 or 2.0. So let's look at the benefits of additive manufacturing. The There are several technical benefits, and there are several business benefits. So if you look at the market resilience point of view, additive manufacturing is uh, it means that even when the market changes, you can change your models, you can change your products, you can change your market, and still use the same manufacturing facility of additive manufacturing without going into change in your productions. For example, there was this Chinese toy microscope manufacturer. They used to sell this toy microscopes at $70 to USA, but due to economic war between USA and China, their product got uh, thrown into a larger tax cycle, so that they went from $70 to $90. And in order to capture that market, what they did was they have to change the entire manufacturing side. They have to change their product design. They have to change their materials of the products. The glasses were replaced with plastics. Metal screws were replaced with metal plastics. So that eventually, and also had to fire a lot of people. Eventually, their cost of production again went below $60, and then they could sell at $70. This change is not required if you are looking through additive manufacturing, to manufacture through additive manufacturing. That is why it is called as a market resilience. Some of the same machines, as I've told you, that you can change the products. If you want to make a bottle today, you can make a bucket in the next day in the same manufacturing structure. But if you look at injection molding, or which is called also called a formative manufacturing, you won't be able to do that in a single day. You have to make a new mold, which will cost you, which will also has a lead time of about a month, depending upon, or maybe more if it is very complex. So lower lead time is one of the things that additive manufacturing can give you. I will provide you with an example how lower it can be. mass customization, that each of the product that you are making will can have a different design. So that is called mass customization, which will be suitable for a particular human being. Also, additive manufacturing supports the designs which is CNC, which is a subtractive manufacturing, or the molding, which is the formatic manufacturing. Uh, Designs which cannot be satisfied with CNC or molding, additive manufacturing can do such complex designs. And also it can reduce number of parts because of this. I will show a example where people have used additive manufacturing to reduce parts from 100 to 1. And now there is it can also support distributed manufacturing because it's an IoT device. You can start small and grow big with this. A single additive manufacturing machine can be as low as 8,000 rupees to 11,000 rupees, and it can go in 30, 40 crores as well. Depends upon where, what kind of businesses you want to start, where you want to start. Depends upon it's a friend of the uh, startups, you can say. Obviously it can go into many manufacturing sectors. I will describe that in the later part of this talk. This is the example I was talking about. This is called a Ka band 4x4 monopulse array antenna. The larger part on the top, you will see the RF component. Beside the RF component written, that is the larger part, which used to be manufactured with CNC, subtractive process. And with 3D printing, you can see on the bottom side on the hand that 2 or 3 feet antenna got converted into that small size antenna. It reduced 100 parts into one. Obviously the size is startlingly very different. uh, Reduction in lead time was from 11 months to 2 months. Can you imagine the cost you save for manpower in doing so? Reduction in 20% production cost and 70% in 75% in non-recurring cost. Reduction in weight by 95%. This is particularly used for satellites, so you can imagine reduction in weight by 95% is very beneficial to such a product. Now what you have to also look at in terms of sustainability. This is addition, so it does not waste any material while you produce it. The CNC by definition is a subtractive process, means you take a large a block of material and then you cut from it. So the whatever you cut it out is a waste material, or it goes into recycling if you for some of the materials, not all of them. So looking at the advantages of technical and businesses, here is what global trends are of markets in additive manufacturing. This is a projection in 2024 for the 2030. It is $88.3 billion, and India is projection is we will reach $1 billion around 26, 27 if we keep on the same pace as this global scenario. Potential trends of this year industry, the biggest increase in 3D printing is in agriculture, and yes, it is agriculture, not aerospace and defense. This you have to understand that what is the structure of agriculture in India and how much it can penetrate that. You can look at this enormous amount of increase from 23 to 24, where 87% of has been reported. Biggest increase in 3D printing is in agriculture. Also, other trends are there. Look at one of the trends that 70% of the surveyed businesses printed parts in 2023 than in 22. So it's growing. It never is. It's not going down. It's growing. So industry trends are very bullish from this report, which has been published by Hubs. So whereas it is in the hype cycle in 20 around 2018, there were 200,000 parts that was mass produced by Adidas uh, for its shoes. And so you can see, although most of it is for serial production, but you can look for mass production in people has achieved. Last year, a small company actually produced 1 million parts in 2023 in a year. So that's a particular definition for high volume, and mass production is now possible with additive manufacturing. The other side of the potential, if government looks at it, when government looks at it, they not only look at the potential in market form, which most industries do, but they also look at the benefits to the people. So if you look at the sustainable development goals, 17 goals are there from the United Nations, and out of the 17, or 15 can be served by is additive manufacturing, and this is huge. And the reason why you can do that is its flexibility to address manufacturing, and the number of technologies in the processes, the processing technology, the manufacturing process technology is very large. That is why you can address so many sectors. So let's look at why you want to do it. In case of industrial revolution, the first industrial revolution was mechanization, and then it went through electrification, automation, digitization in Industry 4.0, and now it is going through personalization or human in loops for Industry 5.0. So I have studied a particular picture. I will show you more on that in later. That if you make mud coolers, and you will be surprised that that can be done with additive manufacturing. Apart from looking at very advanced technologies for space and defense, you can also make mud coolers out of using this digital manufacturing process. I have shown on the right hand side the 3D printed one. On the left hand side, in the mechanization, that is the typical mechanical chakki that people can do. And why do you want to move from this industry 1.0 to 5.0 is that you create more higher paying job by using a 3D printer instead of for your population only mechanization. For the industry 5.0, you will get more high paying jobs doing the same thing. Kulhad maker can earn more by using additive manufacturing. So when we started our journey at the Ministry of Electronics and IT, there were 18 other strategies or policies. 18 countries had different policies for additive manufacturing. We were the 19th one, and since then, this was 2022. Since then, uh, right now it has 33. Uh, 33 more 33 total in strategies or policies of additive manufacturing. So now 33 countries have different policies. So it's growing like anything. This is only 2 years later. Okay. So these are the ones which has been added after 2022, after release of this. So let's look at why or what we said in our national strategy. Why we wanted to do it is now clear, that we want to transfer from industry 1.0 to take the advantage in the industry 5.0 or 4.0. And when we do that, what we how we are going to do it, that's the policy that we may released in 2022. The primary target was 1 billion 5 years. 2025, we said in our policy, but we think it will take another 2 years to achieve that. Primarily the strategy was to bring in those technologies which are already available in the market and deploy it in India. But in parallel, we also create new technologies, and that means everything from entire value chain of technologies, from material, machine, process, softwares, and printed products. Um, that is the development part. So we want to create a new technologies for India, which are affordable to India, and also deploy the existing technologies into the market. So development and deployment, these are the two arms of this strategy. And we were supposed to do it with self-sustainable centers in PPP model. And right now there are 7 such centers which are running in India, which has been initiated. Some of them has gone through a good 3 years, but some of them has gone through less than a couple of months. So it's a ongoing process at this moment. We wanted in the national strategy NSAM, we wanted to create 50 India specific technologies, 100 new startups, 500 products, 10 existing, this 50 new technologies in 10 existing and new manufacturing sectors, 1 lakh new skilled manpower, and of course, awareness of our adoption of AIM in products. So these are the some of the examples of what we are doing. We are on the left hand side. These are the deployment side that we are doing awareness programs and also encouraging industries to come in and settle down in India and manufacture. On the right hand side, the development part, where I have shown only one center's work, which is ongoing, still ongoing. This is material, machine, DFAM, 3D printed products. I will show some of the technologies, the breadth of the technologies that you can do with additive manufacturing is mind-boggling. In case of this top chip packaging, uh, electronic components making, lithium and battery manufacturing, these are all possible. And also mud coolers are possible. This is why it is very interesting to work on. These are the centers that we have already created, and we are working to create some other all over India. Uh, so these are the 10 sectors that will be represented, that we are targeting. Some of the sectors that we have already introduced are medical device sector, optoelectronic components, then optical computing chips, and then renewable energy and distributed manufacturing, then agriculture and food processing. Then we want to start also on the digital toy, then sustainable packaging, smart sustainable packaging, then agriculture in the open field. So there are various different sectors we are serving, and all the manufacturing sectors are also served through NCAM, which is in Hyderabad. So if you look at the initiatives of Government of India for Industry 4.0, the additive manufacturing, which is part of the Industry 4.0, Ministry of Electronics and IT actually does this for this country. Let's keep this. So this is the output till current the financial year 2023. The financial year 2023, that our target 50 will be completed in 2028. Out of 50, we have already started working on 25. 30 startups have come up. 40 products are under work, design and development. 5 sectors are have been already introduced. Manpower, 16.7 thousand has been trained or awared. 10,000. AIM market is now $350 million. We will reach by 2028 $1 billion. We are putting our fingers crossed, and also working on actively to grow beyond $1 billion. Industry partners are 26 for these centers, publication 67, IPR 15 filed, where out of 55 planned. Technology 11 has been transferred to industry, and we have also got, I think this is old data right now, it is should be around the 25 crores. So let's look at one of the technologies so that you can understand what is how we are attacking each and every uh, sectors, how AM can introduce itself and bring in those advantages. That's what I was talking about. Look at this on the right hand side. I said CAD design, and there are about 8 steps of processing. And you will be surprised, this was in a clean room, and the footprint for this 8 steps is about 2200 square feet. What we did was we replaced this conventional process with this DLP technology on the left hand side. The machine you can see is a local machine, and it this replacement of 3D printing Uh, so the entire eight processes converted into this 3D printing one process, and you can see instead of 10 different processes, it's shrunk down to three different processes. Additional benefits, the cost reduction from that initial investment was 25 crores, whereas this machine is and its investment is around 10 crores. So sorry, for 2.4 crores, about 10 times reduction is cost. If you look at the volume, that machine's footprint is about 2 feet by 1 feet. So from 22 square feet to 2 square foot, there is a enormous amount of decrease in the footprint. Also, the volume that we are expecting from this manual device is about 1,000 packages per day, which means that from the conventional printing, which was able to do some samples of around two or three in a month, now it can convert into thousands of packages per day. That is a enormous increase in of volume. So when somebody says that additive manufacturing cannot achieve volume, it is not true anymore. It used to be 10 years back. So this is an example where we have been working for over 30 years with this material technology. Where this is a space-based technology which we supply to ISRO, and this ISRO utilizes this technology for its satellites. And it's still on the IRS satellites, which are still running in the space at this moment. And we have converted that technology through this 3D printing even commercially viable now. Okay. So coming back to that mud cooler thing, the reason why I want to introduce this is a very important part is to look at uh, the s- traveling from this business case from industry 1.0 to industry 5.0, why it is going to give you more profit out of it. So at the bottom, I have said there is a manual process. If you look at it, a very skilled labor will give you about 4 or 5 cups per minute, whereas the mechanized one, partially electrical one, will give which you can find 3 rupees or 5 rupees on the street vendors of tea, and this will be 15 cups per minute. These are factories that are coming up, that are works, and the whole process of these factories is provided in this through this pop die casting mold, pop, plaster of Paris, and then you use a molder, which is a powered machine, and it is about 20 rupees per hour power consumption is there, and the machine cost is about 8,000 per machine. Uh, the soil that is used for that is your working capital, 50 gram per. It is actually free because you can just use any soil wherever you are working, wherever your factory is. You can just go to the back and dig out some soil and make some coolers. So the material is free. And after firing, the approximate cost, production cost, is about 40 paise per minute. When you do that, then if you look at the investment, is, let's say, about 10,000 rupees for a single machine, and if you expect a 50% margin with one machine, then your operation for 5 hours, 1,000 pieces per day, production cost at 50 paise per piece, you can, the bulk price at factory door should be 1 rupee per piece. Now if you look at the production cost in around Delhi, it is 80 paise per piece, and the bulk price is a 1.5 at the factory door. And if you look at the retail price for the tea stall, it is 3 rupees per piece. This is how it is right now. This mechanized industry 2.0, partially electric factories produce this kind of coolers, mud coolers. But if I look at a machine, right? If I look at a 3D printing, the 3D printing machine, the material cost is high at this moment, rupees 15 per piece, and the machine cost is 1.5 lakhs per machine, per machine. Okay, and if I produce it with firing, it will cost you about 4.2 rupees per piece. Now this you will think that it's not making me a compatible you cannot compete with the existing industry, but you don't want to compete either. You don't want to disrupt the industries that are already there. You want to introduce the 3D printing where you can achieve better profit margins without going into the same market. So what market you should target with 4.2 rupees? If you go to Chayos, you will look at this Kulhars where they have a stamp, right? Logo. You can see on the 3D printed one, you can have branded cups, right? This branded cup concept is used by few um, Kulhars like in Chayos, right? But they will sell you a tea in 200 rupees per cup or even 300 rupees for a coffee. This at 4.2 rupees is still manageable for that business, but not for a chai wala on the street. You can export, right? You can export. And if you look at the local same analysis that I did for the industry 2.0, you will find that there is 1.5 lakh investment, and with the same 5 hours and 50% profit margin, you can produce 75 pieces per day with the production cost of 4.2 and selling price at rupees 10. You will make about 22,000 per month, right? So the return on investment for the machine is for 200 days. This is not bad. Think about a woman in their home buying such a machine through some banking loans, and then they can earn about 22,000 rupees per month without doing much, because once the machine you take, you just feed the material to make it. There is nothing you need to do other than feeding the material. And you, so the manpower training here will be very low. Okay. High technical manpower is not required for the manufacturing part, but it is required for the design part. So if it already designed, women from home can actually earn about 22,000 per month. So let's say 20,000 per month. But is it going to be 10 rupees per piece? And what is the market? So if you look at Amazon.com, right, this one clay cup is being sold at 278 rupees per piece. If you look at Amazon.in, this one clay cup is 200 ml, which is a smaller piece. It's 50 rupees per piece. And if you look at non-Amazon online sales of a teacup like this, which is still clay handmade, right? It is 45 rupees per piece. So it's 10 times profit margin. And if you sell it in New York, they are selling in New York. One guy is selling coolers at $8. Okay, so if you look at $10, it will means you have 800, 900 rupees per piece. So that is huge profit margin that anybody can do while sitting at home without doing much if we introduce. So you can see how much industry 5.0 is going to give you, right? So that's why I said move towards high paying job market using AI. So what is the opportunity in terms of Indian manufacturing sector? I've done this exercise by myself and for around 40 sectors of this country, manufacturing sectors. What I've found is that about 39 you can do. AM will be able to give you process technology for manufacturing. The only one which is not cannot do is 17 IT and BPM, which is not manufacturing but basically a service. So if you look at the Make it India initiative, the primary sectors or the focus sectors of the Make in India 2.0, these are the 27. Okay, sorry, these are the 15. I've got it wrong. These are the 15 sectors of manufacturing sectors. There are other sectors which are service sectors, which are 27. These 15 sectors, all of these can be served by AM. Okay, this is very important to know or note, because one of the things that you will can look at is how to introduce aim in a profitable way into our manufacturing where government is giving focus. So you will be having a lot of schemes to promote these sectors, right? So you, if you can jump on the bandwagon and convert industry 2.0 to 5.0, you will be earning more out of it. So that is the key part where additive manufacturing can contribute. So now coming to what we are doing, obviously those 7 centers, one of the center is National Center for Additive Manufacturing. You can look at its outcome in 1.5 years, and it's pretty much they have started, and they are working very hard to grow the Indian market. But here lies a problem that we are looking at industries where industry needs to come on board now. We have set up a structure through NCAM. It's a Section 8 company. It's easy to deal with your problem sets. Indian industry particularly needs to come on board, particularly in co-funding the technologies and market growth. Only focusing by government of India will not do the job. If you want to really focus on bringing the aim market to about $10 billion or $20 billion, industry needs to jump in. If you do not come into that structure, then it will be a slow growth. It will be a 10 years, 15 years. I don't know how long it will take to jump from this 1 billion target to 5 billion target. So what you do is you come to this website ncam.in, and also just register yourself. We are also working to create a ecosystem, digital twin ecosystem for through NCAM, where everybody will be registered so that they can look at what is the ecosystem, who needs what. One of the biggest complaints from industry is we don't know who is doing what, and we agree on that as well from government of India. So we are creating this portal for you at where you come in and register, and then you will find yourself your requirements can be catch on, and there could be a dynamic policy making with government of India where we can understand the requirements of industry in real time. So that is my presentation today.